Hello everyone, welcome back to the third part of my SMO Junior mock paper review for 2024. We have already had two parts where we have covered all the way up to question 14. If you have missed out on those or if you haven't tried the questions on your own, they are linked in the description below. Please do try them. We have also mentioned quite a few things about how the SMO Junior questions, the style, some general strategies. Another thing which I guess I should mention as we are getting into the so-called second half of the paper is that the questions in the SMO are not in order of difficulty. They are also not supposed to be in random difficulty. There will be more difficult questions behind and there will be more easy questions in front, but there will be a scattering of not so difficult questions behind as well. So my suggestion as you do a paper is to not do it in order strictly and get stuck and get very demoralized. If you feel that the MCQ are easy, please do the MCQ first, but at some point do flip through the rest of the paper, look at all the questions and see if there are some easy ones behind which you can do. In this video and the next one, as we do the rest of the 11 questions, I don't think I'm going to be able to say which are the easy ones, but you will generally find that there are some that you feel are actually quite doable, and that is the whole point. Questions do not go strictly in order of difficulty. Alright, so question 15. Evaluate this thing. Now, one of the things about Olympiads is that you don't have a calculator, and if you are new to Olympiads, you also may not be very comfortable doing mental calculations. Still do the calculations anyway, do them carefully on paper, but do not have an unduly low bar of how much calculations you're willing to do. Now, this is not to say that you should calculate 3 to the power of 18 and 3 to the power of 13 and then try to cube root it. You can't do that. But what I would do is to try to figure out what is going on with the number 2186. Something clearly is weird about that number, because if they wanted to have a true random number, they would have used the number 2024. I certainly would have. This must be there for a reason. If you already know what is there for, good for you. If you do not, then what I would suggest is to write down some powers of 3. So I'm not going to go all the way. It doesn't take too long until you realize this is what is going on. 3 to the 7 minus 1. Well, it makes sense to look at powers of 3 since this whole question is about powers of 3, but now we know what exactly happened. So in reality, this is a question where what you have inside is a bunch of powers of 3. I'm not going to continue calculating. Right? Also, do not overestimate your ability to calculate, because even if you can calculate 3 to the 18 correctly, that does not mean that we can cube root the thing. Cube rooting is the problem. So this is probably the best we can get, and there must be some algebraic justification for why this will simplify. I'm noticing that all of these are powers of 3, and so I do want to do a substitution for the purpose of simplifying this. The substitution that I'll do is to let x be 3 to the power of... Now I want a choice that makes all of this nice. I'll pick 6, because 18 is 6 times 3, and I'm cube rooting, so it makes sense to start off with x cubed. 13 is x squared and an extra 3. 3 to the 7 means x and extra 3. And hopefully at this point you recognize that this is just x minus 1 cubed. So therefore, 3 to the power of 6, remember, is 729. So your answer is 728. For numerical stuff like this, you can always try to do a little bit of a sanity check. Now what I mean by a sanity check, number one, your answer should be less than 3 to the power of 6. So that makes sense. That's in terms of size. Number two, in terms of parity, this is odd minus odd plus even is even. So the cube root of an even number should be even. That's number two. Next up, question 16. For the maybe 2% of you who are watching this and know French, you would actually know that un plus nous plus uns, someone who knows French is now going to scold me, un plus nous plus uns is actually 1 plus 1 plus 9 equals to 11 in French. That has no relevance to anything else I'm going to say. It's a classic arithmetic. Each different letter represents a different digit. You will have seen these kinds of things in primary school Olympiads, usually written out vertically, not always, but usually. The first digits at the front are not 0, and it just asks you to solve this. Now, some of you are fans of these kinds of questions because you think, oh, good, I like this kind of logic puzzle. Some of you do not. My suggestion, if you don't like it, skip it first. But please come back to it later, because if you are stuck, these kinds of questions can be done, in the worst case, with a little bit of guess and check. I say a little bit, please don't let it be all guess and check. The second thing that I want to say about such questions is that they are Olympiad questions. Now, many of these kinds of things are computer generated, but they can be solved by a computer only by brute force because there may not be a nice logical solution. For something that comes out in an Olympiad, there should be a logical solution that a human can perform. So in this case, first thing that I observe is that these are different. So somehow I've managed to have a carryover, and the carryover surely can almost be 1. This also changed. And so in order to have a carryover, this must also have a carryover of 1 or 2. Which means that this is probably going to be E is 8 or 9 in order to get a carryover from the 1 or 2. However, n is not 0, so n is at least 1. And the only way you can possibly get a carryover is that E plus the carryover is at least now 11. That will fix everything in place. So this is 9. This is 2. This is 1, and this is 2. Now once you have gotten this, then things are relatively simple because this is also 9. This is also 1. And so this is also going to be fixed. F is 7. This is the juncture where I remind you that digits cannot repeat, and so if you have used up 1, 2, 9, and 7, you're left with 0, 3, 4, 5, 6, and 8, where u plus u plus u gives a carryover of 2. So certainly this can only be possible if it's 8. 3 8s is 24. So your answer is 2149. I feel this is relatively easy for an arithmetic. That was what I was trying to achieve. The difficulty of these kinds of arithmetics does differ from year to year whenever they show up, but they should not require blind guessing. That's the one universal thing that I can say about any such Olympiad question. Okay. Question 17 up next. M and N are positive integers such that their HCF is equal to 2024 and their LCM is equal to 6072 followed by a lot of zeros. Put a lot of zeros for a bit of a laugh, but on a serious note, please make sure that you count the number of zeros correctly. I'm afraid of counting wrongly myself, so I'm going to just split it into blocks of 3, which will tell me that there are 15 zeros. For some of you who tend to have like a bit of difficulty with this, count it twice. it will turn out that if you counted the number of zeros wrongly for this question, you are okay. But that's not always true. Okay, so HCF of m and n is 2024. You need to know the factorization of 2024, which I can supply here. That's the HCF. And the LCM is this thing here. Now, this thing here, 6072, is just 3 times of 2024. 15 zeros means 10 to the power of 15, but you can further factorize that into 2 and 5, and so I can combine the 2's as well. Okay, so this is your HCF and this is your LCM. Now, I set the thing to be so large by design because certainly if it is so large, nobody can actually try to guess numerically the values of m and n. So nobody can numerically guess the values. So instead, my suggestion would be that you understand the other way that we do HCF and LCM, which is that the HCF just grabs the smaller exponents and the LCM grabs the larger exponents. So it becomes like a mini puzzle where m and n get to choose. If the lower is 2 cubed and the larger is 2 to the 18, it means that there's 2 cubed and 2 to the 18. It could go either way. Now, 11 and 11 means that they both must have 11. 23 and 23 means they both must have 23. Then you have got the stuff that is just only in the LCM but not in the HCF. These ones also are either in m or n, so you can treat it as if it was 3 to the 0 and 5 to the 0. Now the question asks you how many possible pairs there are. Take note that this does not have any constraint on which one is larger, and so by default whenever it says pairs, it means that the order matters. The order matters, and so you have 2 choices, 2 choices, and 2 choices, which gives you 8 possible pairs. Question 18. ABC is a right-angled triangle with angle A being the 90-degree angle, AB is 30 and AC is 40. So straight up, I'm giving you a 3, 4, 5 triangle, but I'm scaling it up to 30, 40 and 50. Now D lies on side BC such that AD equals to K, where K is a positive integer. What is the sum of all possible values of K? And note that D cannot coincide with the points B and C. In other words, you cannot say that D is down here and AD is 40. I don't allow that. Now, clearly 40 would be the furthest away you could be from A. So K is less than 40 is pretty obvious. Now, you can imagine that as I slide it here, right? So at some point, the distance when I move along here will go down, 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 down. It will be 39, then the distance will be 38, then 37, then 36, 35. And I would just want to know as I move along here, where is the minimum going to be? Yeah, and that's where you're shouting through your screen, stop! Because you know that the closest point would be when this is at a right angle. Now this allows me to mention similar triangle pattern number 4. Right? In each part of this video, we have mentioned one type of similar triangle pattern. As far as I can tell, this should be the last one because there are no more geometry questions in the rest of this paper. But this is the final similar triangle pattern. Nested right-angled triangles because, well, the small triangles now also share the same angles as the big triangle, and so therefore they are all 3, 4, 5 triangles as well. So if they're all 3, 4, 5 triangles, then at this location it would be 4/5 of 30 or 3/5 of 40. Technically, I know that this is 18 and 32 by the same ratios, but that is not very important to me. What's important is that the minimum is 24. The maximum, as we have said, can go up to 40. On the other side, it only goes up to 30, so that doesn't help. You just add all of this up. There are a total of 16 numbers here. And so the correct numerical answer is 504. Question 19. A and B are real numbers which satisfy this equation here. What is the largest possible value of B? First thing to note is that it's only one equation. It's only one equation, and so if it's only one equation, normally there would be infinitely many solutions. So if you are looking at this question and you don't know what to do, for a question that asks you what is the largest possible value of B, very funny but effective method that I like to use is always to ask something like, why can't B be 100,000 or 1,000,000 or 99999? Try something humongous and ask what happens if B is very big, right? So imagine if B is, let's say, 1 million. Now you're going to end up with A squared minus 4 million A plus 5, lots of zeros, equals to 24. So we ask ourselves, what is going to be the problem with this? And the answer is that, well, probably this means that A squared minus 4 million A plus 5 trillion will be a lot more than 2024. How will we know exactly that will be a lot more than 2024? Would be by completing the square, right? Because if you want to know how small could it be, you would complete the square. Now that's a thought example, thought experiment, where if you now throw this out, you can say, well, I don't need to use 1,000,000. 1,000,000 is just taking so much time to write. I can still complete the square anyway. By considering the first two, and that would be A minus 2B squared. A minus 2B squared would be A squared minus 4AB plus 4B squared, which leaves us with B squared. Now the idea is very simple. It's very tempting, and we certainly should complete the square for the B part as well, because it means that the largest possible value of B, this is non-negative, so therefore the most that this can take is the 2025, which is 45 squared, so B is at most 44. So whenever a question asks you for the largest, just like all the way back to our question 2 in the multiple choice section, If you know what's going on and you know what to do, great. If you don't know what to do, sometimes just picking an extreme example where you're quite certain it would not work will give you the general reason why it will not work, and then you can apply it to the specific question on the numbers that you actually care about. So for this video, I think we'll end on this question number 20. So for question 20, this is the number A, B, C, D, E, F is a 6-digit number. It's 1, 2, 3, 4, 5, 6 in some order. And then A is divisible by 1, AB is divisible by 2, and so on until A, B, C, D, E, F, the n itself is divisible by 6. Let S be the sum of all possible values of n, find S over 6. It's not surprising that the value of S can be divided by 6, since n is always a multiple of 6. But it is also not surprising that when a question asks you for this, it's probably just that it's too big. It's too big because SMO answers are up to 99999, 5 digits. So I can't fit 6 digits into an answer sheet. Of course, for this paper, you're typing it in. The actual SMO is shading in 5 spaces. Shouldn't be a 6-digit number. Let's look at what actually we can say easily. So you've got the numbers A, B, C, D, E, F. First thing is the 1, 2, 3, 4, 5, 6 divisibilities would force E to be 5. That's pretty clear. The second thing is that B, D, and F are all even in order to be divisible by 2, 4, and 6. 1 I don't really care about. And so that means A and C are just 1 and 3. Now, with not much else to go on, I am just going to try the 2 possibilities of A and C being 1 and 3. Okay, so let's try first of all if I put 1 and 3 into A and C. So I put 1 and 3 down there, then 1 is settled, 2 is settled, 3 is not settled, because ABC is a multiple of 3, means A plus B plus C is divisible by 3. Now out of 2, 4, and 6, it is quite easy to tell that only 2 works. You then look at 4. The test for 4 is the last 2 digits. So the 2-digit number CD is divisible by 4. Again, out of 34 and 36, only 36 works. You put 4 at the end, and then you check that for 6, it is clearly even, and it is divisible by 3 because the digit sum, in fact, is always going to be 21. So that is going to be fine anyway. So 1, 2, 3, 6, 5, 4 is solution 1. Don't forget that we have the other case where I put 3 and 1 in the other sequence. So I put 3 and 1 in the other sequence. I have 3, 1, and 5. I follow the same logic. This still has to be 2. This still has to be 6. This still has to be 4. And that's it. So you add them together, you get 445, 308, and then you divide that by 6. You get 7, 4, 2, 1, 8. And that will be it for this section of our review. For the last section of this video, I will go through last 5 problems, so as to just say some final comments on the SMO Junior. So thanks for watching again, and see you in a couple of days.